Welcome, Kerbal, to another exciting episode here. This is actually a special edition. As I'm recording this, SpaceX is about to launch its first NASA mission that's not to the International Space Station, an actual space probe. The probe is named Tess. Tess is kind of the continuation of the Kepler probe, which detected planets in, I think, thousands of extrasolar planets, planets in solar systems beyond our own. That mission is on its last legs or completely non-operational at this point in time. But the TESS mission will work on a similar principle, although Kepler only stared at one little tiny piece of the sky for the entire time. Later on in its life, it actually stared at two different spots in the sky. However, TESS will actually stare at the vast majority of the sky, and it will get a good idea about planets through other solar systems throughout the entire solar system. So this is my little stand-in. The TESS mission is an infrared telescope. Real TESS mission is not infrared, it's 4 visible telescopes, but it's about the same size as this infrared telescope, and there isn't a visual telescope in stock Kerbal space program. It has some thrusting capabilities, has a couple of solar panels, and it will be detached on a very highly inclined orbit, and it will use its thrusters to get it into a little bit better of an orbit. This little thing here is not actually a part of the Kepler mission, or the TESS mission, excuse me. This is related to a tweet that Elon Musk sent out, which is that they are going to try, not with this mission, but I'm just going to test it anyways, to land a upper stage using a, quote, party balloon. So this is the closest approximation that I think that they're kind of going for. This is something similar to some stuff that I've heard coming out of JPL, some of the tests that they've done to land on Mars. Although there's a number of experiments that are being discussed. The rest of this, although it doesn't look like a Falcon rocket, it's actually fairly similar. Real Falcon rocket, of course, has much more delta V, but that's okay. So we're going to go ahead and launch this. So the TESS mission is supposed to launch today, April 18th. I am about ready to stream it. It's still got about an hour to launch as I'm recording this, but go ahead and launch it anyways. Wow, it looks kind of different. I don't know why that is. Huh. Must have changed with the visual settings somehow. Yeah, that's okay. So this is my close approximation, and this is fairly accurate for the Falcon 9. Of course, the Falcon 9 has 9 engines, this only has 4, but it's really hard to build an engine or a spacecraft with 9 engines in the space program, so I opted not to. The upper stage has an engine that looks a lot like the Falcon upper stage, but it's quite a bit more powerful than the true Berlin engine, and so we'll probably scale back its power a little bit. Now, the real mission is going to go into it's going to do a flyby of the moon for an overall correction. That has not been done very often. It's only been done by, to my knowledge, one other spacecraft, which used the moon flyby to get into geostationary orbit. They found a clever way to save some fuel. Wow, I'm a little bit off. You know what, I'm going to take some time to separate. We'll pretend that upper stage is going to go land. like the real Falcon Heavy will do. We'll go ahead and deploy our fairing too. I do not believe that Tess will attempt to catch the fairing. The fairing catching has typically been done in the East Coast, or the West Coast missions, and Tess will be launched from Cape Canaveral. So we'll go ahead and warp a little bit. You'll probably notice that the sound sounds hopefully a lot better than normal. I'm testing out a new sound system, so let me know what comments you have about this. Hopefully I've got my issues all resolved. Kind of interesting that it's still so close, because we haven't actually accelerated anywhere. So the real mission is going to do a 2-burn second stage, and then possibly one for a disposal. My understanding of the disposal orbit is actually going to dispose into a heliocentric orbit. Not sure if that's the case. There's been a lot of rumors both ways. You see that engine, of course, is much, much more powerful than the real Merlin. That only took a matter of seconds. You can see some of my little test experiments that I was doing earlier. I did in the live stream that I did previously. Okay, so what we're gonna do, add a maneuver here. Now the real test mission, the Falcon will not do a direct insertion like I'm doing here. Yeah, we'll go ahead and do this. This will be fine. Okay, so what we're going to be doing here is executing the flyby of the moon. We're going to do a similar flyby. The flyby is going to raise the periapsis, much like you see here, and it's also going to make it inclined. The specific inclination of Tess will make it so it doesn't have to use as much fuel, which makes everything much, much easier. 15 seconds, this is ridiculously overpowered. In all of the real KSP reality systems that are much more realistically powered systems, it takes a couple of minutes to do this burn. And here it's only going to take 15 seconds. That's okay. The short burn time will allow us to have a more efficient burn. Okay. So we're going to do a little bit of an inclination adjustment once we get out. We probably won't hit the 30-degree inclination that the real test mission will have, but we didn't start out that inclined either. Oops, let's try it the other way. You can see our inclination after the flyby is increasing quite rapidly. Okay, that'll be good enough. It won't put us fully inclined, but it's actually not bad. It's fairly close to what it's actually going to be. Okay, we'll roll with that. Now at this point in time, I'm going to detach Tess. And we are going to switch to the booster. The booster is going to do a slight retrograde maneuver, and it's going to... we're going to set it on a course where it will re-enter. Real Falcon top stage, upper stage would use thrusters to do this, but we don't have any, and it's okay. Our little reaction wheel will do. It's just slow. Now, like I said before, the separation will actually happen quite close to Earth. Very unlike this mission. And it's believed that to dispose of it... why? I don't have any electric charge. Silly me. Okay, I don't need no electric charge. So what I just did is I turned on the cheat, because in reality the system will have plenty of batteries. So we'll just deorbit this a little bit. Just so it's no longer on a moon intersect. Good. So we'll go ahead and approach this sap oasis, and we'll set it on its final path. Especially since Tess won't actually have to do anything here. So from this point forward, Tess will be primarily burning into Apple Oasis to control its attitude. Okay, so we're in a heavy disposal orbit. I'm actually going to raise that just a little bit, because this is a little bit lower than I want to test this. This probably won't actually land successfully, but we'll observe what it does, to say the least. Did I do this the wrong version? Oh. I need to destroy that, I was supposed to use a coupler, not a decoupler. We'll try some slight surgery on this. Let's see here, object thrower. go. Okay, so that just took the decoupler off, so like it was supposed to. Unfortunately, I forgot to do that. So you'll see here that we have an inflatable heat shield, similar to what I suspect the party balloon concept is that Elon Musk was talking about earlier this week. Okay, so let's go back to Tess. So Tess is just minding its business. It's not actually gonna do much, but it'll fly by the moon here. And it's leaving, and it's on a good course. Okay. So let's keep going. I think. Yeah. Trick is that once Tess is in the right orbit, we're going to do a little bit of a burn to have it go into a 3-day period, which is half of the moon cycle. Now this is not the right phase, so what is our orbital period roughly? It is about 2 days, so we're going to go ahead and just leave this alone. We're going to switch back to our upper stage. And this heat shield inflation would probably happen a little bit later on once it was actually fairly close to the atmosphere, but minor detail. Okay, we're speeding up, we're getting close. Now, Elon Musk said that they're going to use a giant party balloon to slow it down. I think I'm rotated the wrong way. And now it might be a little bit difficult to actually get it to work right. But the idea is that they'll use this balloon as kind of a parachute or a heat shield combination. It should be probably the other way, but this is just a demonstration. It'll slow it down sufficient to the point where it can re-enter the atmosphere safely. And then they'll use probably something similar to the thing that they're trying to catch the fairing with to catch it. This is going wildly because I'm trying to fight it and point in the right direction. We'll burn a little bit of fuel just to lighten the load. Although this is really burning in the wrong direction. Now you know that this was going to be a crazy idea because Elon Musk felt the need to preface it with the fact that this was going to be a crazy idea. So, I know it's dark, but you can see that slowed us down way down. And this kind of acts like a parachute. So it protects the vehicle, it acts as a parachute, and it can even protect it when landing. So all in all, it's a very useful concept potentially. It'll be really interesting to see when they actually get around to trying this out. I had kind of the impression that they were going to go full speed with the BFR, but that might change now. See that this is still going way too fast to actually capture, even if I burned all of my fuel. Didn't expect that would spin so fast. Guess I'm just kind of flying now. it's still going to crash and it will blow up, but it's a start. And one could imagine that if they landed in a vehicle, that they could, or landed in a giant bouncy castle, as Elon Musk put it, that they could potentially do something well. So now we're going to go over to the test mission. We're going to wait one orbit. Yeah, we're not in a very good phase to do this. We're actually very, very close to the... Wait a second, is this my test mission? Haha, this is my test mission, never mind. You can see that this is the test mission that it'll eventually go into through its own volition. And you can see that, here, rather than me fiddling with it, let me just show you what it looks like. No, this isn't the test mission. Yeah, it is. As every time it reaches the Apple Oasis, the moon is about 180 degrees off of each other. Although this orbit isn't absolutely perfect, so like the test mission should hopefully be. What will happen is when the moon is on this side, it pulls it a little bit this way. When the moon's on this side, it pulls it a little bit this way, and it'll stay even. And that way they're able to save a lot of fuel. Kerbal space program physics only models two-body physics. It doesn't model other things like the moon here, so therefore it doesn't actually affect anything. Anyways, this is the test mission in a nutshell. What will happen at this point in time, solar panels will already have long since been deployed here, is it will spend each one of these orbits most of the time it'll be in a 13-day orbit. For most of those 13 days, it will be pointing at 4 different patches in the sky, looking at them for planets. And then once it gets here closest to Earth, Kerbal, it will have a very high data link, and it's moving too fast to do anything useful, so it's going to transmit all of the data it's collected down, and that will save some power, and it will, at a time when it wouldn't otherwise be able to do anything useful. So that's all I have for now. Let me know if you guys have any questions about tests or any other mission or anything else space related. If I don't know, I'll be able to find the answer, I hope. Thank you guys very much for joining me, and let me know how the sound is in this video and any other comments you guys might have. Thank you much, and we'll see you next time.